Alright, so here we have a train moving at constant speed of 70 kilometers per hour. We might as well move this into meters per second just because that's just always what we tend to work with here. So 1 times 10 to the 3 meters per kilometer times 1 hour per 3,600 seconds, which comes to 19.44 meters per second. So we have 3 directions that were given here. So for our first one, it says that we move east for 46 minutes. So I'm going to go ahead and set up an axis system and say that and use X, Y, or I guess I might as well in this case use I, J. I'll just have to be consistent. So I hat, J hat for east, north, and then west will be negative I hat, and south will be negative J hat. So for the first leg, I'm moving due east. So my velocity is 19.44 meters per second I hat. My time is 46.0 minutes times 60 seconds per minute, which comes to 2760 seconds. And so the distance, or the distance vector that I've traveled, is VT, which is the 19.44 times the 2760 seconds, which comes out to be 53,654.4 meters in the I hat direction. Now for my second part, I'm traveling at an angle of 46 degrees east of due north. So that's my angle, 46 degrees. There's my velocity vector. And I can decompose this into V cos 46 and V sine 46. So my velocity is my magnitude, V times cos 46. No, I'll do sine first, sorry. Sine 46 in my I hat plus V cos 46 in my J hat, which is, so my velocity in this case is the same one, so 19.44. So I can put this in my calculator and get 13.984 and 13.504. And these are meters per second. Now the time I'm given for this second section is 21 minutes. Converting it to seconds is 1260. And so then my displacement is my velocity times my time. Which comes out to be and of course, the seconds will cancel here in the I hat direction, and this distance in the j hat direction. Okay. So then I'm just going to start circling these a bit just so I can find them later. And so then my third leg of the journey here is due west for 78 minutes. So my velocity is now my magnitude in the minus my magnitude in the I hat direction. So that's just what was my velocity here? Minus 19.44 meters per second I hat. My time is 78 minutes times 60 seconds per minute, which comes out to be 4680 seconds. So then my displacement is my velocity times my time. $46.80 seconds, which comes out to be, where am I here? Minus 90,972. Oh, 979, sorry. 0.2 meters in the I hat direction. And so now we get to the actual questions. So what is the average velocity and direction counterclockwise from east? So I guess it's looking for an angle. So our total displacement is each of our individual displacements summed. So that's our first one was 53,654.4 meters in the I hat. Our second one was this guy, and our third one that we just calculated was this guy. So we just sum these all up, remembering that I hats go with I hats and J hats go with J hats. In this case, we only have one. So it comes to negative 19,704. Excuse me. All right. Okay, so that's my total displacement. And so my velocity, is going to be my displacement over my total time. My total time is just the sum of all my times. So we had 2760 seconds plus 1260 seconds plus 4680 seconds. And so this, when you sum them all up, comes to 8700 seconds. So my total velocity is my total displacement over my total time. So it's this guy. Over my total time, so 8700 seconds. And so then my total velocity vector comes to minus 2.265 meters per second I hat plus 1.956 meters per second j hat. And so the angle, just to sketch this out here, so we've got 2.265 in here, 1.956 in here. So then this angle is, so tan theta is equal to opposite over adjacent, so 1.956 over 2.265, which leads to theta equals 40.81. If we're looking for the angle that's counterclockwise from east, though, then we're looking for this angle, which I'm going to call phi. And so then phi plus theta is 180, which means that phi is 180 minus 40.81, which means that our phi is 139.19 degrees. And so then there's our average velocity and our angle counterclockwise from east. So if we check the solution, we get our total displacement, our average velocity, I guess I could have done the magnitude. I would say that's average speed, but if I'm going to do the magnitude, I can do that as well. So my magnitude of my velocity would be the square root of 2.265 meters per second squared plus 1.956 meters per second squared. So just square the individual distances or the individual components. And for this, I'm just going to have to open up a calculator and say 2.265 squared plus 1.956 squared equals, and then root. So then our velocity, our speed, our average speed is 2.99 meters per second. Which, if we compare to what they found here, about 3, that must just be rounding differences. And the theta, in their anti-clockwise theta from east, they got was 140 degrees. We got 139. So again, I assume that's just rounding differences. So that looks good.